For centuries, the Taj Mahal has been celebrated as a monument to love. But what if it was also something far more extraordinary? What if hidden within its marble walls lies a geometric code so precise it challenges everything we know about historical engineering? Using cutting-edge aerial LiDAR and precision high-altitude drone scans, researchers are uncovering something astonishing. Sub-centimeter symmetry, cosmic alignments, mathematical ratios so advanced they rival modern computer modeling. And one question now echoes through archaeology. Was the Taj Mahal merely a tomb or a giant celestial machine built in stone? Stay with us, because what we're about to reveal may completely change the way you see one of Earth's most iconic monuments. Imagine seeing the Taj Mahal not as tourists do, but as pure geometry. Recent high-altitude LiDAR scans have generated ultra-detailed 3D models of the entire 42-acre complex, mapping every dome, garden axis, platform, and minaret with astonishing precision. And the results? Shocking. From ground level, the monument appears beautifully symmetrical. From above, it appears mathematically perfect. Researchers mapping the site found alignments accurate to astonishingly small tolerances across enormous distances, a level of planning difficult even with modern surveying tools. Remember, construction began in 1632. No GPS, no laser levels, no digital modeling. Yet somehow, builders maintained a flawless one-to-one mirrored layout across the vast Yamuna riverfront terrace. How? How did 17th-century architects achieve something resembling precision engineering centuries before modern CAD software? That mystery deepens when you examine the structure's hidden central axis. At first glance, the Taj Mahal seems symmetrical. Drone data suggests something far more deliberate. Nearly every major structure mirrors another. The mosque to the west, the Jawab, or guest pavilion, to the east, perfectly balanced, reflecting each other like architectural twins. A central axis runs through the Great Gate, through the gardens, through the water channels, through the marble platform, through the mausoleum, and directly through the cenotaph chamber. An astonishing demonstration of bilateral planning. Even more remarkable, the famous 4 minarets are not perfectly vertical. They lean slightly outward. And no, that was not a mistake. It was intentional. A brilliant engineering safeguard so if an earthquake struck, they would fall away from the central tomb. At the same time, that subtle outward tilt preserves visual symmetry when viewed from below and above. Beauty, meeting structural physics. And suddenly the Taj Mahal stops looking like decoration and starts looking like precision engineering. But then researchers noticed something even stranger. The symmetry didn't stop with Earth. It seemed connected to the sky. Now things get fascinating. When researchers overlaid site geometry with historical astronomical orientation, patterns emerged. The entire complex aligns closely with cardinal directions: north, south, east, west. But beyond orientation, some scholars have explored whether solar positioning played symbolic or functional roles. At sunrise and sunset during certain times of year, light enters the monument in striking ways, illuminating interiors with almost choreographed precision. Coincidence or design? Then there's the central dome. Its proportions and orientation interact with seasonal light in ways that suggest advanced understanding of solar movement. And from above, the entire complex resembles not just a palace, but a giant geometric diagram. Some even compare its spatial planning to sacred cosmological layouts. Was it merely symbolic? Possibly. Was it scientific? Perhaps partly. But one thing is undeniable. Its astronomical precision raises profound questions. How much did Mughal architects know about geometry, astronomy, and spatial mathematics? Maybe more than history has credited. And hidden in the marble itself, there may be even deeper clues. Look closer, much closer. The marble surfaces of the Taj Mahal are not merely decorated. They're encoded with mathematical order. Floral inlays repeat with astonishing proportional consistency. Calligraphic panels enlarge as they rise upward, an optical correction making them appear uniform from the ground. Think about that. 17th century optical engineering, embedded in stone. Some researchers have pointed to recurring proportional relationships, sometimes compared to classical harmonic ratios, including approximations associated with the golden ratio. Whether deliberate or emergent from traditional design principles, the elegance is undeniable. Then come the gardens. From above, the Charbagh layout reveals geometric grid planning of extraordinary discipline. Water channels, walkways, reflecting pools, all arranged with mathematical rigor. Even more astonishing, some architectural historians note that aspects of Mughal precision rivaled, and in some respects exceeded, contemporary monumental works elsewhere in the world. That's a bold claim, but when you examine the data, it's hard to ignore. This wasn't just architecture. This was geometry elevated into art. But what does all this mean, and why does it matter now? What if the Taj Mahal preserves knowledge we've underestimated? Not lost magic, not alien theories, but something arguably more impressive. Human ingenuity, master surveyors, astronomer builders, stone craftsmen operating at extraordinary sophistication. Some experts argue this reflects a level of architectural physics that rivals principles now embedded in computer-aided design. Not because they had computers, but because they understood proportion, optics, load dynamics, and geometry at astonishing depth. And modern digital scanning is finally letting us see it. These discoveries are also reshaping preservation. Using LiDAR, researchers can create digital twins, exact 3D replicas preserving every measurable detail, every angle, every stress line, every geometric relationship, protecting the monument for future centuries. And maybe preserving clues history overlooked. Because the Taj Mahal may not simply be a wonder of beauty, it may be one of humanity's greatest mathematical masterpieces. So, was the Taj Mahal only a monument to love? Or was it also a coded achievement in geometry, astronomy, and engineering far ahead of its time? The deeper technology looks, the more mysterious it becomes. And perhaps the greatest secret isn't hidden in the marble, but in the minds of the people who built it. What do you think? Ancient genius? Or evidence we've underestimated historical science? Tell us in the comments. And if you love uncovering incredible hidden truths about our world, subscribe to Amazing World Facts and join us for more mysteries science is only now beginning to explain. Because the world is far more amazing than it seems.